Hi, and today I'm going to look at 10.5. I'm going to split up this section into two parts. The first part I'm going to look at particles connected horizontally, and the second part, which will be your lesson for the following day, will be looking at particles connected vertically. So, to begin with, I'm going to go through in detail example 11 on page 169, this example here. So, if you have that opened up in front of you, I'm going to draw the diagram for this example. So it says two particles, P and Q, are connected. So, I'm going to draw these particles, P and Q, of mass 3 kilograms and 5 kilograms. This is my particle P and this is my particle Q. It says they're connected by a light, inextensible string. What that means is this string cannot bend, and it's light, so we don't need to worry about the mass. And it connects these particles as though it's one particle. So I can think of this as one particle of mass 8 because it's got this connection here. It says particle P is pulled along. I'm just going to put some forces in now. With a different colour pen. So particle P is pulled by a horizontal force of 40 newtons along a rough horizontal plane. So because this is a rough plane, we will have friction on both of these particles. It says particle P has a friction of 10 newtons and particle Q experiences a friction of 6 newtons. Now, what will also happen in the rope that's connecting these two particles, you will have, because it's a tight rope, you will have tension between these two particles. Okay, so the tension of the one mass will pull the tension of the other mass. Okay, now the first thing we want to find is the acceleration of the particles. Now there will also be forces going up and down here. There'll be a normal force and a weight going down, normal force and a weight going down. I don't need to worry about that on my diagram because when I resolve forces, I'm only going to do it horizontally. So I'm not going to put those in as it may confuse. So I want to, first of all, find the acceleration A. Now what I'm going to do, I'm going to think of this as one complete particle. So I'm going to use F equals ma. The whole system will move at a constant acceleration towards the right because it's been pulled by this force of 40 newtons, and the acceleration will be this constant throughout. Now the forces, if I'm resolving the forces horizontally this way, I'm going to take that as the positive direction. Let's look at what we've got. Well, I've got 40 newtons going positively. I've got friction here, 10 newtons, but that's going in the opposite direction. And I've got 6 here going in the opposite direction. Both the tensions will cancel each other out. So I've got one tension going one way and one tension going the other way. So let's just look at the force again. So the force I'm resolving going to the right. I've got 40 to the right, negative 10 because it's going the opposite direction, and negative 6. that will equal the total mass, 5 plus 3, which is 8, times the acceleration, which I would like to find. So if I put all of this together, I will have 24 on this side equals 8a. So my acceleration will be 3 meters per second squared. Right, part B. That was part A, finding the acceleration. Right, part B asks to find the tension in the string. So when I look at finding the tension in the string, I'm just going to either look at particle P or look at particle Q and ignore the other particles. Now, it doesn't matter which particle I look at, and I'll show you in both ways how I can get the solution for the tension T. So if I was to look at, for example, at particle P, so I'm going to resolve horizontally at particle P. So I'm just going to draw this diagram again. I've got 40 newtons this way, I've got my friction of 10 newtons, I've got my tension of T, and I've got my mass of 5 kilograms. So I'm going to look at F equals ma, using this as the positive direction, and I know the acceleration is equal to 3. So the total force on this particle going to the right as positive is 40 minus 10 minus t equals my mass times my acceleration. So I've got 30 minus t equals 15. So t will equal 30 take away 15, or 15 newtons. So that's the tension on particle P. Now, I said it doesn't matter whether we look at P or Q. So now I'm going to look at Q. So let's just draw another diagram and just resolve on Q. So I've got 3 here. And let's look at what forces I've got just on Q. I've got my tension T, and I've got my friction 6, and it's all moving at an acceleration of 3. So let's do F equals ma, resolving on Q going towards the right. So I've got T, force going to the right, minus 6 going to the left, equals my mass times my acceleration. So T minus 6 equals 9, so T equals 15. So the tension is 15 whether I look at Q or whether I look at P. I will have the same tension. Now this one, looking at Q, was actually easier than looking at P because there was less forces, but it doesn't matter. And then the last question in C says, explain how the modelling assumptions that the string is light and inextensible have been used. Well, a light string has been used, so therefore we do not need to worry about the mass. We're concentrated on the mass of here. The fact it's inextensible, i.e. it's not moving, means that the acceleration of the masses is the same throughout. It doesn't change. Right, so we've had a good look at the first example 11 in section 10.5. What we're going to look at now is a very similar question, and you might want to have a go at this first before I go through it. We're going to look now at question 5 on page 172. Now, the first thing I want you to do is see if you can sketch that diagram yourself, and then we will go through the method. Again, pause the video, have a good go. It's exactly the same as what I've done, and then check what you've done with my method now. So, well done for getting this to get the sketch. So, I've got a lorry of mass M pulling a trailer of mass 3M. So this is my lorry and this is my trailer, just showing them by rectangles. They're connected by a light inextensible tow bar, so we don't need to worry about the weight. The acceleration will be the same. The lorry exerts a driving force of 50,000 newtons. So basically, that's the driving force, okay? That's what's pulling. A driving force is a pulling force to pull the trailer and the lorry forward. And it says the acceleration is equal to 5 meters per second squared, going in the same direction as the driving force. Now, the friction that we've got here, it says the lorry and trailer experience resistances of 4,000 and 10,000 newtons. That's your frictional forces. And don't forget, we have tension in this tow bar connecting the lorry and the trailer. So we're going to treat it as one particle going along, or we may look at, to find the tension, just looking at the lorry or just looking at the trailer. So the first question says find the mass of the lorry and the trailer. Okay, so to do this, I'm going to look at the whole system. I'm going to put it all together and treat it as one big particle. And I'm going to resolve going in the direction of the motion on the whole system. So you just write this at the beginning to explain to the examiner what you're doing. So I'm going to use F equals MA in this direction. So let's think about the forces. Well, the tensions are going to cancel each other out. I've got 50,000 going to the right, that's positive. 4,000 to the left, negative. And 10,000 to the left, negative. Equals my whole mass, 4m, times my acceleration, 5. Okay, now once you've got this formula, life becomes really easy for you. So let's go through that again. F equals ma, resolving it in this direction towards the right. So the forces, I look at all the forces, positive, negative, negative, equals the whole mass times the acceleration. Now, if I solve that, I will get m, which is the mass of the lorry, to be this much, and 3m, the mass of the trailer, to be this much. So now I have answered question A. Right, part B. Find the tension in the tow bar. Right, so what we're going to do now is either look at just the trailer or just the lorry to find the tension T, the same in each case. Now I can see the trailer has less forces. It's only got the 10,000 and T, whereas this has got T, 4,000 and 50,000. So I'm going to look at the trailer. Doesn't matter, I'll get the same answer for either of them. So what I'm going to do, you don't have to draw the diagram out again, but in ease of my presentation, I think it will be easier for you if I do draw this out. Now I worked out the mass to be 5,400. This is the trailer I'm looking at now. I'm going to put my forces on. I've got T going this way, tension, and friction going the other way. So that's all the forces I've got on this trailer that are going in this direction in terms of the movement, the direction of the acceleration of the trailer. So F equals ma. So T will be positive, 10,000 will be negative, equals my mass times my acceleration. And if I work out T, this will become 37,000 as my answer. Okay, so that's the tension in the tow bar, and I would get exactly the same answer for T if I did it on the lorry. I will do that in fact now just to prove that that is true. So let's just look at the lorry. So the mass here is 1,800. It's on a flat surface. I've got 50,000 this way. I've got my tension T, and I've got my friction 4,000. So let's do F. Oh, it's accelerating in this direction. A is 5. So your diagram is really important. So F equals ma, 50,000 towards the right, minus 4,000 minus T equals my mass times my acceleration, which is 5. So if I put 5 in here instead of acceleration, and if I work all that out, I get the same answer, 37,000. Okay, so that's question 5. Now, before I finish this video, you can actually go to the questions now. I think I will do question 9 separately. Question 9 is exactly the same for A and B as what I've just done. It just talks about thrust here, but you don't need to know, that's the last question where thrust is introduced. You don't need to know that for the other questions. And Mr. Bennett has done a lovely video on this question, so I will send you that link to have a look at that question. Okay, so the questions I would like you to do for exercise 10E, for this is part 1, remember I've only looked at horizontal motion, on page 171 is 1, 2, 3 and 8. 4 questions. Set your diagrams out neatly please for those, really clear diagrams, okay, showing all your forces in a horizontal motion. If it says no friction, then there's no forces on the particle. The ones I've been through had frictional force. Looking forward to your answers.